Welcome back to Blockchain Pill. My name is Alex, and today we'll watch yet another Dominic Williams video. Ever since Dominic Williams revealed this demo of an AI existing on the Internet Computer Protocol blockchain, we saw a shift in the people's perception about the Internet Computer Protocol. ICP is the only blockchain which allows an entire AI to exist in a canister smart contract, which is a feat that was not achieved by any other blockchain out there. Without further ado, let's jump straight into the video, which I'm sure you will love.
Dominic, who's coming up to the stage, and he'll give an insightful talk on AI, and that is a smart contract, why and how.
Hello, everyone. I'm Dominic Williams. I'm the founder and chief scientist of the DFINITY Foundation. DFINITY is the largest contributor to the Internet Computer Network. And today we're going to talk about AI that runs as a smart contract on the blockchain. So that's something very different. There's a lot of blockchains for AI, tokens for AI being created today. This is the real deal. AI that actually runs on the blockchain in fully decentralized form. So for those of you that don't know, DFINITY Foundation is probably the blockchain industry's largest ongoing R&D operation. We're blockchain maximalists, and we're trying to drive what we call a blockchain singularity, where all compute eventually is migrated to blockchain. We were established back in 2016, and the Internet Computer now represents the product of more than 1,000 person years of R&D effort. We're a Swiss not-for-profit, headquarters is in Zurich, and we have one of the world's largest teams of famous cryptographers, and generally the team includes a lot of kind of well-known and very brilliant cryptographers, computer scientists, engineers, and that's why we have so many research papers and academic citations and things like that to our name. And the team really is a mixture between early blockchain, early crypto people, and people from organizations like Google and IBM.
When you look at most blockchains out there, the teams is either anonymous or it's a bunch of marketers. At DFINITY, all the 270 team members that are working on building the future of the internet are doxed and available on the DFINITY website. So I think this is a welcome change from, the usual thing that happens in crypto. I think it's undeniable that what they're doing is working. So that's a food for thought for the people that say, the tech doesn't matter, the team doesn't matter, it's all about hype. It's about hype until it's not about hype anymore, and then the technology will actually matter.
So the big deal with the Internet Computer is that compute is now on the blockchain itself. And that's very different to what we're used to in Web3. Generally speaking, in Web3, the online service is built on traditional tech, and just the tokens and little bits of DeFi logic live on the blockchain. The Internet Computer is the first third-generation blockchain, and it brings everything onto the blockchain. So it's really blockchain playing the role of cloud. If you go to the Internet Computer dashboard, you can find it at dashboard.internetcomputer.org. You'll see that today, the Internet Computer is processing about 330,000 Ethereum equivalent transactions a second. That's measured by looking at the low-level number of instructions processed by the virtual machine on the blockchain. And that staggering number, which far exceeds the compute of being performed on all of the other blockchains in the world taken together, reflects the fact that the Internet Computer blockchain is providing cloud-like services. It's the world's first third-generation blockchain. The Internet Computer supports something called canister smart contracts. It's a much more advanced evolution of traditional smart contract software. And developers can build anything with canister smart contracts. So full stack decentralization is happening today. Full stack decentralization occurs when people build things that run 100% from the blockchain. So today there are social networks running on the internet computer blockchain, and they're decentralized end to end. There's no traditional IT involved whatsoever. All of the data, all of the media, all of the computation, the user experience, everything lives on the blockchain. People have built order book exchanges, DEXs that look like a CeFi exchange, like Coinbase or Binance, are running fully on-chain. And the latest development is that people are using the internet computer blockchain to run fully decentralized AI that runs in the form of a smart contract. And that's what we're going to talk about today.
Other blockchains cannot host a phone photo on-chain, and on the other hand, ICP allows you to build an entire dApp on-chain, and most recently, it allows you to host an AI in a canister smart contract. This is miles ahead of its competitors, and I think that this is only just the beginning.
If you're trying to understand how's this possible, how can a blockchain run AI? Well, ICP smart contracts are kind of like blockchain on steroids. They're smart contracts that are ready for anything at all. So one internet computer smart contract can store up to 400 gigabytes of data. Currently, it runs in 4 gigabytes of main memory that's dedicated to the contract. The memory is persistent. That limit's going to be raised in the next couple of months quite substantially as we're moving to a 64-bit model. They run WebAssembly bytecode. They support something called reverse gas, which means that the smart contracts pay for their own computation. So when a user interacts with a smart contract, they don't have to create a transaction, or at least they don't have to create a transaction that makes a payment for gas. The smart contracts pay for their own computation. These smart contracts run in parallel. For the technical people here, the internet computer implements something called an actor model. The smart contracts can process transactions that run over multiple blocks. So, for example, if you invoke a smart contract and it performs a long-running computation, it's not limited by the amount of computation you can do in a single block. The transaction can span multiple blocks. These smart contracts can process HTTP, which means they can serve web experiences directly to users and interact directly with users through browsers. They're fast and low cost. And when I say fast and low cost, everybody in blockchain says that their smart contracts are fast and low cost. But if you take the most efficient traditional blockchain and then you compare it to the internet computer, when we say fast and low cost, it's orders of magnitude more efficient. Orders of magnitude more efficient. These smart contracts are multi-chain capable. There's something called chain fusion technology, powered by something called chain key cryptography. You may have heard of it, that allow internet computer smart contracts to maintain balances on different blockchains, invoke their smart contracts, that kind of thing. They can make calls into Web 2. You can fully automate these smart contracts with DAOs. So no decentralization theater. You can have a DAO that has complete control over something like a social network, providing an internet community with true Web3 ownership. And finally, these smart contracts are AI capable, and that's what we're going to talk about today. So, a few days ago, I did a demo of fully decentralized AI on X. I showed a neural network running as a smart contract performing image classification. So it can look at an image and it can tell you what's in the image. And if you take the URL of my Twitter profile, scroll down, you'll see that video. It's a world first. That's the world's first demo of quite a sophisticated AI running on the blockchain itself. We believe that AI will be the beating heart of Web3, and I invite you to dream a bit with me as we take a look at some potential ways that AI smart contracts can be used. Example number one, Ethereum safety. How can an AI smart contract improve Ethereum safety? So this is a very, very common problem. you can go to a website like Etherscan, and you can see the Solidity code behind an Ethereum smart contract. But it doesn't really help you with that question. How do I know if I should trust this smart contract? Is its Solidity code kosher? Most people aren't Solidity engineers, and most Solidity engineers don't even have time to go and audit other people's smart contracts. So you can see the Solidity code, but is it vulnerable to a reentrancy bug? Are there any backdoors that make a rug pull possible? Does it contain some malware? Might this Ethereum smart contract attack another smart contract? Might it do something malicious? So AI smart contracts on the internet computer can solve this problem. They can scan the Ethereum blockchain. They can match the code hash of a smart contract to its Solidity software code. And they can verify there are no reentrancy vulnerabilities. They can verify there are no backdoors. And they can verify that there's no malware inside. And then they can produce a certification that can be displayed by a website like Etherscan. So when the user is looking at their Solidity source code for a smart contract, they can see that it's been certified by an AI audit, and thereby get some additional reassurance that the smart contract is safe to use. All right, second example, autonomous KYC. So KYC is know your customer, and it's what systems have to do that allow you to interact with things like security tokens. So a future problem is that DEXs are going to want to enable degens to trade security tokens. Things like stock tokens, real-world assets, and tokenized commodities like gold. The challenge is that once you get into that field, there are a lot of regulations. And almost certainly, people, for example, that are issuing stock tokens are going to require that people buying and selling them have performed KYC. There's some kind of know your customer involved. And this is a big challenge because a DEX is meant to be decentralized, right? It's a decentralized exchange. That's what DEX stands for. And that means it should be created using smart contracts. And how on earth can a smart contract KYC somebody? How can a smart contract even interoperate with a company that performs KYC? It's a big problem. And how on earth can all these DEXs enable security tokens to be traded? Well, again, AI smart contracts provide a solution. So I mentioned that video of a demo that's on my X Twitter profile. And that was a demo of an AI smart contract performing image classification, a neural network inside a smart contract performing image classification. Well, that image classifier has been retrained and can now do face recognition. And this is a very, very cool thing because now you can have a KYC smart contract with AI inside that can, first of all, verify that somebody's a live person. It can ask somebody to, look left and right, hold 4 fingers up, that kind of thing. And then it can match that live person to an identity document like a driving license or passport. And once it's done that, it can record their identity, probably in encrypted form, and issue, for example, a Web3 credential to an authentication system like Internet Identity, which can now enable the degen to get into the DEX and trade security tokens. Nice, right? Third and last example. I've called this an intelligent catalyst. What I'm talking about is an AI that's a kind of Delphi for your team, startup, company, government department. Obviously, it's a large language model, so without getting into the technical details, that's our objective. We want to have large language models running on the internet computer as soon as possible. And there's a lot of work optimizing the network for that task ongoing at the moment. Here we imagine an AI, we'll call it a Delphi, that works for, say, a startup company. And this AI is connected, first of all, to the company's confidential sources of information. It's probably connected to Slack and looking at messages on Slack. It's connected to Calendar. It's connected to email. It's connected to GitHub. It's connected to Jira. And it's, ingesting all of this information. And it's also talking to the team members, right? So members of the team are, giving it information like, my team is blocked by this problem, or I've got this great idea to improve this thing. Then people are interacting with this AI and they're saying things like, hey, can I get a meeting with such and such this afternoon? How near are we to closing this deal? What's our current monthly burn? There'll be permissions, right? You probably need to be the CFO to ask, what's our current monthly burn? Maybe someone in PR can say, hey, are there any good ideas for PR? So you can probably see that it's a very powerful thing. Like, these AIs are really going to drive the efficiency and effectiveness of teams and organizations forward. But there is an issue here, right? What happens if this AI gets hacked? If this AI gets hacked because it's running on traditional IT infrastructure, then the hacker is going to have access to all of that organization's most confidential information. The hacker's going to get access to the feeds. It's going to see all the Slack messages, the emails, the calendar entries, the private repos from GitHub, the tickets in Jira. It's going to see everything. The hacker will see everything. So what happens if this gets hacked? It's going to be bad. What if this stops? If it's running on a traditional server, what happens if it stops, if it breaks? Well, we can imagine, right? So 20 years ago, we all used to be really, really good at using a map to navigate the countryside or to navigate a city. We could look at a map, we could work out our route, we could memorize the route. But now, today in 2024, most of us have lost that skill. Why? Because we have sat-nav on our phone, right? We no longer have to use a map. We just look at our phone. And that's very convenient, saves us a lot of time and stress. Fantastic. But the same kind of thing's going to happen with AI. We're going to learn to lean on AI for so many things. And organizations that have this kind of Delphi AI that catalyzes their organization and acts as a nexus for information that glues everybody together, if that AI stops, that's going to really disrupt the functioning and operation of the company, team, whatever. And traditional IT is not secure. You can use firewalls and cybersecurity, but traditional IT isn't secure and it's not resilient. So what's the solution? Of course, the solution is to run the AI, which is something like a large language model, using a smart contract. And now, of course, we get past that problem. AI smart contracts are tamper-proof. They're guaranteed to run the correct code against the correct data. So they're kind of like very resistant to hacks, very secure. They're unstoppable. Blockchains guarantee that they're always going to run the code. So that's another way of saying they're highly resilient. And of course, optionally, they can be autonomous, so you can control the AI smart contract using a DAO, or if you want, make it non-updatable, right? And AI smart contracts are intelligence that's fully decentralized, and today they're only possible on the internet computer.
Once again, all other blockchains are struggling to host a phone photo on the blockchain, and there we have the Internet Computer Protocol aiming to have large language models running entirely on-chain. I think the difference is obvious, and people are complaining that the DEX volumes on Solana are crazy, the whatever. Yeah, the meme tokens, 1 out of, 10,000 they'll launch every day. One of them is doing well, and so on and so on. But it's all an attention game. And right now the attention is on Solana. But when it will come down, to the technology and to who is who, the Internet Computer Protocol will win out of all other blockchains. You can go to Solana and gamble if that's what you want, but if you're in it for the long term and if you want to invest in a technology that is actually reshaping the way we do things online, there is only one competitor, and that is the Internet Computer Protocol. And with that, we're done. I hope you enjoyed the video. Thanks for watching, and I'll see you in the next video.